Welcome to the online lectures for software engineering. In today's class, we'll be discussing 3 topics. Coming on to the nature of the software. Now, the first point is software is intangible. Now, within software is intangible, there are 2 points. Now, software does not exist in physical form. Well, now we very well know that software does not exist in physical form. That is, you do not have a physical thing where you're going to store the software. Now, you can probably store it in a pen drive or a CD, but software is not present in a physical form. It is basically line of code that is present within a specific program. The next point is it is hard to see the efforts involved in the development process. Now in here, if suppose you are developing a program that is complex, so a complex program is going to take a lot of time. First, to identify what are the different features that are going to be there, what are the different functions that you are embedding within the software. You're going to perform different types of testing. So it takes a lot of time. So in here, but the end product is again line of code. So in here, by checking the line of code, it is difficult to identify how much effort has been put up within the development process. The next point is software is easy to reproduce. Now in here, within software engineering, whenever you're designing a particular software, you're going to focus on reusability. That is, you're going to design a software by keeping in mind that this software or this particular component that you're going to use, components are nothing but different parts within the particular program. Components. So the components that you're using within the software, they should be reusable. Now, only the first point in here is only cost and development process. Now in here, if suppose you're designing a software and here you're using components that are reusable. So in here, you're going to just put in the money only for the development process. That is in here to put all the things together. The next one is, if suppose you want to generate another copy of the same software, it is easy once it is developed, because in here, you've got one particular software. Now in here, this software, you want to develop a software that is similar to it. So what you're going to do, you're going to make small changes within the software. You do not have to start from the beginning. You do not have to gather all the requirements, the features, functions, testing. Each of the things need not need to be done. Whether you're just going to add the small changes and then you're going to test the software. So if you just want to reproduce the code, it is very easy. Then next point is, building a similar software requires less time. Now, as I've discussed that building the software, this requires less time. Whereas if you're making the same software, so in here, you just have to replicate the code. The next point is, software does not wear out. Now in here, within software does not wear out, it deteriorates with maintenance as changes are introduced. Now in here, if suppose you have a software that's being designed and you're just embedding multiple updates within the software. A lot of updates are there within the software. So in here, the software becomes very complex and also it becomes slow. So in here, the software deteriorates with maintenance as changes are introduced. If multiple changes, some changes within the software, they are necessary and they need to be done. If suppose you're making multiple changes within the software, completely changing the behavior, then the software can deteriorate. The next point is slow down in performance as time passes. Now, as time passes, multiple new technologies are evolved and multiple new projects are developed on these technologies. So in here, the software that was built on an older version of technology, this becomes slow when compared to the software that runs on a new technology. The next point is it suffers when not updated regularly with respect to the surrounding environment. Now in your first point, you've seen that it deteriorates with maintenance as changes are introduced. But in here, if suppose you do not have the minimal updates and the minimum updates or the support that are required, if those are not done, so the software is also going to suffer. Now the suffering means it might slow down, it might crash. Well, this is how the software is going to suffer. Then the next topic is software myths. Now, within the software, what are myths? Myths are assumptions that people make. Now, in software engineering also, these assumptions are made by a different set of people. It can be made by customers, it can be made by developers, it can be made by managers, the team members. So in here, Pressman describes, now Pressman, the textbook that we are referring is Roger S. Pressman, the prescribed textbook, the 6th edition in here. Now this person in here told that he's described a number of common beliefs that these people are going to have, customer, developers, and managers. He also describes them as misleading attitude that may cause serious problems. Now, why these assumptions are going to cause serious problems? Because you're assuming something that is not true. So when you're assuming something that is not true and you're going to work according to it, you might end up in a serious problem. You might damage the software. The next is there are 3 different types of myths. You've got managers myths, developers myths, and customers myth. Coming on to the first myth, that is by the management. Now in here, divide the screen into 2 parts, the myth and the reality. Now in here, within the myth, the myth is we already have a book that is full of standards and procedures for building a software. That is, you've got each and every step written so that you can just read that and develop a software. Now, won't that provide my people with everything they need to know? This is a myth that you've got a book that is going to have each and everything that you need to develop a software. Whereas the reality is, now there might exist a book that has got a few standards or procedures for building the software. But do the developers use this particular book? The developers use the book or not? Then are the software practitioners aware of its existence, that these developers, do they know that this type of books also exist? And the next one is whether this book, whether it is complete, that is, does it have all the procedures, all the techniques that are built in on a day-to-day life everywhere? As technology is evolving, different different procedures, models, standards, practices are implemented across the world. So whether this book is going to have all of this standard, that is the question. Then is it adaptable? Adaptable means if you suppose you want to run the software on a different computer, on a different operating system, whether that program will work properly or not, based upon these standards that are defined on the book. So these are the different questions that are going to arise. That is, this is completely a myth. You cannot have a book that covers all the technologies, procedures, everything. Even if that books exist, it is not going to be complete. It is not going to be adaptable. And this type of books, it also does not show you that if suppose you've got a specified time period to develop the particular software, whether you'll be able to develop the software in that particular time. So the answer to all these questions is no. So this myth turned to reality does not stand a chance. The next myth: if we get behind schedule, we can add more programmers and catch up, sometimes called as the Mongolian horde concept. Now in here, whenever an end user is going to come to the developer that this particular software needs to be developed, he's going to give you a time frame. Now what is a time frame? Time frame means within this specified time, your software should be completed. Now because they want to launch the software or something. So in here, this myth is that if suppose you're behind schedule, that is, if you're not able to complete it within the specified time frame, you can just add more programmers and the work will be done. This is a myth. Whereas within the reality, adding people to a late software project makes it later. That is, in here, if a particular person or one particular engineer is involved within the development of the project from the inception phase, that is from the beginning. Now when he is involved from the beginning, he knows what are the different requirements. When he knows what are the different requirements, he can interact with the end user and he might know what are the different features or functions that he wants. Now when you communicate, you get a clear idea of what this end user wants. So he clearly knows each and every change that the end user wants to make within the software. Like, he's completely involved within the software. So if you just add another engineer at the end of the phase, he just wants to complete the work. He will not be able to develop a software that the end user wants. Now, as new people are added, people who may be working must spend time educating to the newcomers. Now, there's one more drawback, that if you're adding a person at the end of the phase, means he needs to be taught each of the things from the beginning. That is again going to waste time. And in here, we have added these number of people so that you can catch up on the missed time. The next point is, if you have to add people within the particular project, you need to add them in a planned way. In a planned way means they need to be educated from before. If they have to come and work at the third week of the development of the project, then they should have the full insight of the project and all the requirements, the goals, the risks that are involved for the software. They should have an idea of that, and they should coordinate very well with the existing team. The next myth is, if I decide to outsource the software project. Outsource means, now if you are giving this project to be built by another organization is building the software, that is called as outsourcing. If I decide to outsource the software project to a third party, that third party is your organization here. I can just relax and let the firm build it. Now again, this is a myth. The reality is, if an organization does not understand how to manage and control the software project internally, it will invariably struggle when it outsources software projects. Now in here, every software project that you're getting or every contract that you're getting to build a particular software, you're just outsourcing all the projects, then it is a bad reputation of the company, because the team members, they are not able to manage the project and they are not able to control the project. So in here, this is a myth and that should not be implemented. A good organization is going to develop the projects on its own. They are going to properly manage it, properly control the project. If you're just outsourcing all the projects that are coming your way, means at the end you're not going to receive any projects. The next is, these are the myths for customers. Now within the previous one, we have studied the myths for management, that is the different managers. The second one we are studying is for the different customers. The customers are people that are going to use your software. The first myth in here is, a general statement of objectives is sufficient to begin writing programs. Now in here, what is objective? Objective means what is the goal, why we are developing this particular software, why the software is being developed. That is an objective. Now in here, if you just have the initial general statement, means the goal, it can be like a 2 or 3 line statement. Now from that 2 to 3 line statement, you can start writing the program. It is a myth, because you cannot write the program until and unless you have a complete statement of each and every feature that the end user wants. And now in the reality, we'll discuss in here, a statement of requirement is not always possible. That is, a comprehensive, stable statement of requirement is not always possible, because in here, the end user at first instant, that is within the first meeting, he might not be able to deliver all the requirements that he wants within the software. Within one line statement or or if you say even a 1 paragraph statement is not going to justify his requirements within the software. Statement cannot justify the requirements. An ambiguous statement of objectives is a recipe for disaster. That is, if you have one particular statement like this, if you just say that I've got everything within a paragraph or within a statement, then it is a recipe for disaster. That is, in here, everything is not clear, and software that you're going to build, put all your time, resources, and people in, it is going to be a waste of time. Now, unambiguous requirement means, if suppose the end user states one specific requirement. Now in here, there's a possibility that this requirement means 2 different things. It might also mean the first thing, or it might also mean the second thing. Now if the first thing was assumed by the end user and the developer assumed the second thing, so in here again this software is going to suffer. That is why one statement is not possible to capture all the requirements. Now these requirements can be effectively gathered only by way of communication. That is, the end user and the developers are going to sit together and they are going to talk about what do you mean exactly by this thing that you want to be implement within the requirement phase. Now in here, this can be the end user or it can be the developer's view for developing the software. The next myth is software requirements continuously change, but change can be easily accommodated because software is flexible. Now in here, change cannot be easily made within the software. Now changes cannot be made within. Now in here, there are a few projects that accept changes within the software development. Now in here, changes can be done at two phases. The first phase is at the beginning of the software. Now in here, changes means when you've gathered all the requirements. After gathering the requirements, when you're making a plan or you've already made the plan and you're starting for identifying how you're going to model the software. So if within this modeling phase, if you're adding the change, whether it can be accepted or not, or within the planning phase, you can add a change. Or after that, you're going to have the designing part where you're going to design the software. So within there are different phases. So in here, you need to identify at what phase changes can be acceptable by the organization that is developing the software. Now in here, if suppose you're making a change at the beginning of the project, then it is going to affect the software very less. That is, in here, the cost impact is going to be less because you have not done the modeling part and you have not done the designing part. If suppose as the time passes and you want to make the changes at the later stages of the project, that is when the project is nearly complete, you want those changes when the software is near to complete, then in here it is going to cost you a lot, because in here all the models that you have made, the code that you have embedded, each of the things will have to be changed. It is going to cost you time, it is going to cost you money. So that is why the changes in the software cannot be made at any instance of time. The next is software myths in a practitioner's view. Now these practitioners are your developers. Now in here, the myth that is told by the developers, or what they assume is, once we write the program and get it to work, our job is done. That is, when you embed all the features, when the coding part is done, the job of the developer or the coder is not done. They think that it is done, but in the reality, the sooner you begin writing the code, the longer it will take you to get it done. That is, in here, if suppose the first phase within development of the software is requirement gathering. Now, if suppose you start writing the code within the requirement gathering phase, within the first phase only you start writing the change. Now, within the later phases, while communicating with the software, you might get to know that there are some certain changes within the software, or some specific statements was ambiguous. They meant two different things. So according to that, you again need to completely change the code. So in here, if you start writing the code at the very beginning phase, it is going to take you a long time to complete the code. Now the industry's data indicate that 60 to 80% all effort expended on software will be expended after it's delivered to the customer for the first delivery. That is, in here, whatever different tasks that you have done in here, whether they are correct or not, whether they are functioning properly according to the end user, you're going to get to know that after the software is being delivered, because this software, when it is delivered, you're going to use it on a real-time system. Now according to this, you're going to get the feedback. Now if any changes are required, then the job of the developer is he needs to make change within the code. So in here, this myth nullifies. Changes in code need to be done in here. The next myth is, until I get the program running, I have no way of assessing its quality. This is a myth. That is, until the program is running, you cannot assess the quality. That is, what quality software is being developed, you cannot identify. That is a myth. The reality is, one of the most effective software quality assurance, that is the one that is most trustworthy mechanism, is when you are going to apply that mechanism at the inception. Inception means at the beginning of the project. Now, when you identify at the beginning only that you want to make a particular software that has got the best quality, it is necessary that you start evaluating everything at the beginning of the project. Now, this can be done by taking reviews from the customer or from the different developers. Now, software reviews are a quality filter. Now, when you take a feedback from the user that he's going to test it, he's going to run a program on it, and he's going to tell a review that whether it is robust or not, whether it achieves the best performance or not, whether it is accurate or not. You're going to identify this. So by taking feedback from technical people, you get feedback upon the performance. So that is called as a quality filter. So before the software becomes running, you get to assess the quality of the software. So again, this myth is nullified. The next one is, the only deliverable work product for a successful project is the working program. Now, deliverable work means the software that you're going to develop. Now, in here, whenever you're designing a particular software, now the software can be completed, that is going to have all the features, and then it is going to be delivered to the end user. Or the second type of delivery is, you're going to deliver the program in different parts. That is, with one update, you're going to have one feature embedded within the software. By the next update, you can have another feature with the software. So in here, the myth is, the only deliverable work product for a successful project is working program. This is a myth. That is, you're going to calculate what you're doing, whether the project is successful or not, you get to know by the working of the program. It states that. The reality is, a working program is only one part of the software configuration. That is, you cannot just judge the entire software based upon one component. Now, these different components include different work products. Now, the different work products in here are models. Now, why are we designing models? Models are designed so that you get a clear picture of what are the different features that are within the software. Now, we are developing models so that the end user and the developer both get a clear picture of what is going to be developed. Then documents. Now, why are we creating documents? Documents are made so that whatever work you're doing, you can keep a track of it, and what are the different changes that were requested, those can also be jotted down. Then plans. Now, within the plan, what you're going to do, you can make a schedule of how you're going to work. You can identify the different risks that the software might have. Now, in here, these are the different work products. Whenever we use the term work product, means work products can be models, documents, and plans. Now, these provide a foundation for successful engineering. That is, if you have got the best model that is going to deliver all the features, if the documentation is complete, that is all the configuration that you're using, what are the different modules that are there within the program, if each of them are accurate, then that is what becomes the foundation for a successful engineering. And it also acts as a guidance for the software support. That is, your success cannot be judged based upon the specific component that is being delivered or the project that is being delivered. The success can be judged based upon the models. Now, when you're creating the model, you get an idea of what needs to be there within the software. When you have the documentation, you have everything noted down. When you have the plans, you identify what are the risks. Then you can also identify how you want to remove those risks or how you want to eliminate those risks within the software. The next one is, software engineering will make us create voluminous and unnecessary documentation. Voluminous means very lengthy. very lengthy and unnecessary documentation and will invariably slow us down. Now in here, you're not making documentation to slow you down, but you're creating a documentation to keep a track of what you're developing. What are the different modules that are there within the software? What are the different features? How you're embedding them? You're going to have different models. You're going to have different diagrams within the documentation so that you get a clear picture of what is being developed. So software engineering is not about creating documents. It is about creating a quality product that is the best version of the software. Now when you have a better quality product, when you have everything noted down, you get to identify whether it is achieving the best quality or not. Now when you have the best quality software, it is going to reduce the rework. Now you've got everything noted down, you can access, you can keep a track of each and every module, whether it is achieving the best quality or not. Because within the previous slide, you have studied that this quality assurance, it should be started from the inception phase, from the beginning of the project. Now when you achieve better, when you achieve a good quality product, then it is also going to reduce the work. And when you have a reduced work, that is less work you have got to do, then it is also going to less the delivery time. That is the specified time frame that you want to deliver the software in, you can complete it before that specified time.